Going to see the new chapter, paper chromatography. In this, we'll see about the introduction of paper chromatography, methodology, development techniques, advantage and disadvantage, and its application. So here, let us see how the paper chromatography works. So introduction to the paper chromatography. Paper chromatography is a type of planar chromatography. This runs on a specialized paper. It is the simplest and most widely used of its applicability to the isolation, identification and quantitative determination of organic and inorganic compound. It was first introduced by a German scientist called Christian Friedrich Schoeben in 1865. There are various type of paper chromatography, that is paper adsorption chromatography and paper partition chromatography. So when we look into the paper adsorption chromatography, the paper is impregnated with silica or alumina, acts as a adsorbent or a stationary phase and solvent as mobile phase. Paper partition chromatography, moisture water present in the pore of cellulose fiber present in the filter paper acts as a stationary phase and another mobile phase used as solvent. In general, paper chromatography mostly refers to paper partition chromatography. So, what is the principle of paper chromatography? The principle of separation is mainly partition rather than adsorption. Substances are distributed between stationary phase and mobile phase. Cellulose layer in the filter paper contain moisture which acts as a stationary phase. Organic solvent buffers are used as mobile phase. The developing solution travel on to the stationary phase, carrying the sample with it. Component of sample will be separately readily according how strongly they adsorb onto the stationary phase versus how readily they dissolve into the mobile phase. So what are the practical requirement? The stationary phase that is present onto the paper used, then application of sample, mobile phase, development techniques, detection or visualizing agents. So these are the practical requirement. So what are the stationary phase? There are different type of stationary phase which are used in paper chromatography, that are Wattman filter paper of different grade like number 1, number 2, number 3, number 4, number 20, 40, 42, etc. etc. are used. In general, this paper contain 98 to 99% of alpha cellulose to 0.3 to 1% of beta cellulose. What are the factors that governs the choice of paper? The paper is chosen based upon the nature of sample and solvent to be used, based on it is for qualitative or quantitative analysis, or based on the thickness of paper. So what are the different type of paper? So we have a modified paper, hydrophilic paper, hydrophobic paper, and impregation of silica, alumina or ion exchange resin can also be made. So look here, what happened when we are choosing the paper, we must look into the nature of compound that is going to be separated. So depending upon the compound, you have to choose the paper and you have to choose the mobile phase. So we have a various type of paper here, that's called modified paper, which is acid or base wash filter paper, glass fiber type papers, and hydrophilic paper modified with methanol or formamide, glycol, glycerol. These are the solvent through which the paper are treated, and it makes a hydrophilic in nature. And in modified paper, it is treated by acid or base, and that brings a desired change into the paper. We have also hydrophobic paper, in which the acylation of OH group leads to the hydrophobic nature, hence can be used for reverse phase chromatography. Impregation of silica, alumina or ion exchange resin can also be made depending upon the use of paper chromatography. So what are the different type of mobile phase we use here? So depending upon the nature of compound to be separated, we have wide variety of mobile phase that can be used. So we can use even pure solvent, or we can use a buffer solution, or we can use a mixture of solvent. For an example, for hydrophilic mobile phase, isopropanol, ammonia, water into in the ratio 9:1:2 is used. In some time methanol and water in the ratio 4 is to 1 is used. But these are not the universal solvent or mobile phase which has to be used. It is prepared depending upon the nature of compound which is under separation. So these are the generally used a mobile phase which has been just quoted in order to show you that they can be in different proportion and they can be prepared. There are other solvent system which can be in N-butanol or normal butanol, glacial acetic acid, water in the ratio 4 is to 1 is to 5. And then we have hydrophobic mobile phase, which contains dimethyl ether, cyclohexane, kerosene, 70% isopropanol. So we have a choice to make a polar or non-polar sort of or hydrophilic or hydrophobic nature of mobile phase depending upon the nature of the compound to be separated. So what are the different type of technique development techniques? So we have already seen this in the when we were learning about the TLC. So I have not gone so detailed about the previous slides regarding the principle and the mobile phase stationary phase used, because we have already seen into the introduction part of paper chromatography where we have discussed about it. So let us see what are the different type of development technique. Once the sample is spotted onto the paper, they are put into the mobile phase and they are kept and they are made to run the mobile phase. The mobile phase can run according to the procedure they are classified into. So they are ascending development in which the solvent flow against the gravity and the spots are kept at the bottom portion of paper and kept in the chamber with mobile phase solvent at the bottom. In descending one, this is carried out in a special chamber where the solvent holder is at the top and the spot is kept at the top and the solvent flow down the paper. In this method, the solvent move from top to bottom, so it is called descending chromatography. And the biggest advantage of descending chromatography is it is much faster as compared to ascending development. The advantage is that development is faster in descending type of in descending type of development technique. But however, you need a special chamber to keep the solvent at the top and the paper below to this. Then we have a ascending descending development technique. In this, we both type of development is taking place. It is a hybrid of two above technique what we have discussed, ascending and descending. On the length of separation increases, first ascending take place followed by descending. This is done in order to have a proper separation when the compound are closely related to get it separated. Then we have a circular or radial development. In this what we do, we just make a circle on which the sample is spotted, and then the wig is given, and which is through which the solvent flow, and the wig is generally made of a cotton, and then the solvent flow throughout the circle made onto the paper, and they move throughout the paper in all direction, and later on the RA value is being calculated. So spot is kept at the center of circular paper. The solvent flow through a wick at the center and spread in all direction uniformly. And then we have a two-dimensional development. In this method, the paper is developed in one direction, and after development the paper is developed in the second direction, allowing more compound to be separated into individual spot. In the second direction, either the sample same solvent or different solvent can be also used depending upon how the separation has happened, and the which compound has to be eluted towards the other side. So the looking into the nature of the compound, we can choose the solvent system. We have a freedom here to design the solvent system.